A revolution in robotics is underway, and I want to enable as many people as possible to contribute to it. Historically, robots have found economic success performing highly repetitive, structured tasks such as production line, assembly, welding, or painting. However, that is changing rapidly due to progress in many subfields and the continual advances of computer hardware. In fact, robots are now starting to be able to approach common problems we see in everyday life. I have several young children, and I would love to have a robot like this perform this task in my house every night. Many of us do this toy pickup ritual every night. We also do the kitchen floor, move all the chairs away, and mop and sweep routine every night. It would be great to automate this. It should produce a meaningful improvement in the standard of living for many people across the world. It's great for the children pickup task. It's even more important from an economic perspective for those with disabilities and older adults, or many people for whom these tasks are a challenge. So for several years while I was at Stanford University, we learned how hard these tasks are. So here we're having an office assistant robot. We call this the please fetch me a stapler problem. So you can imagine the robot that would go through an office environment and pick up things that you've left in other parts of the building. These tasks sound trivial, but when you start to break them into their subcomponents, they actually become quite challenging. For example, you need to deal with hallway navigation, opening doors, computer vision, looking at things that are all kind of the same size and same shape, yet they're different handheld objects. Picking them up, and then maybe operating elevators, maybe doing some voice recognition. You can make these problems sort of arbitrarily complicated. So they're so complex, in fact, and so numerous that it's hard to imagine that one single individual, one single laboratory, or even a single institution could produce truly general approaches to all of them. So as a result, I co-founded the Robot Operating System, or ROS, with fellow roboticists at Stanford University and at Willow Garage. It's a free, open-source middleware that tries to make it easy for software developers to collaborate when developing complex robot software. Essentially, you can create subsystems, and then have ROS will help you link your subsystems together at runtime, so that if one laboratory has experience in computer vision, another has experience in manipulation, you can then combine them even while both of those subsystems are under parallel development. So it started out as helping fetch staplers through buildings as I was a teaching assistant. It's since become much more general purpose and has benefited from the contributions of tens of thousands of people worldwide. I've put pictures there of a few of the platforms that are using this, and we're already starting to see this in the marketplace now. Both in the research domains, which are ranging from household laundry folding all the way up to flexible industrial automation, as well as in many products now that are starting to hit the market. So in our current work, we're looking to scale this up to cloud-based environments where we can have server farms to increase the accessibility of high-fidelity simulation of complex robots and environments, as well as scale it down into more efficient systems that can run down on the firmware of the robotics with the same ideas of mass collaboration. My name is Morgan Quigley. I'm with the Open Source Robotics Foundation in Mountain View, California. Thank you.